Welcome to part 5 of this series on in situ concrete compressive strength assessment, SONREB. Now we're moving on to look at some techniques which are not covered by the European Standard for Strength Assessment, and we're going to begin with the method known as SONREB. The term SONREB is a combination of sonic and rebound. So it is a method of combining ultrasonic pulse velocity with rebound hammer measurements. In simple terms, we measure the pulse velocity and the rebound value at the same test location, and then we obtain a compressive strength estimate based on an equation of the format shown here. The underlying concept of the combined method is that if the two methods are influenced in different ways by the same factor, their combined use could result in a cancelling effect that improves the accuracy of the estimated strength. For example, if we have increased moisture content, the ultrasonic pulse velocity value increases, whereas the rebound value decreases. This is what EN 13791 has to say about SONREB. The combined use of both UPV and rebound hammer techniques with core strength is a useful technique, but the procedures are not detailed in this document. There are some countries such as Italy and China, for example, where the SONREB method is very well known and there are national guidelines for it. And here we can see the SONREB procedure. We measure the rebound value at a test location. We measure the pulse velocity at the same test location. Then we determine the core strength at the same test location. We repeat this at sufficient locations and then use Excel to generate the coefficients. Taking it step by step, we first define our test location. In the European standards, this should be approximately 30 by 30 centimeters, and we measure the rebound value. Now at the same test location, we measure the ultrasonic pulse velocity. And the final step is to take a core and determine the core strength. And then we repeat this at sufficient locations to generate the relationship. In the European standard, we need at least 8. And now we should have sufficient data to generate the coefficients. Once again, for my example, I'm going to take the data supplied by LNEC in Portugal. Here we can see the raw data, but how do we go about getting the coefficients A, B and C? We cannot use a simple scatter chart as we did previously because we have 3 variables. The way to do it in Excel is to use an array function called linist. The first step is to take natural logs of the raw data, and then we used the linist array function on this, and finally we obtain the 3 coefficients. If you're not familiar with the linist function, don't worry, because help is available on the screeningeagle.com website in the downloads section. There you will find a detailed guideline on how to determine the SONREB coefficients using Excel. Even simpler, there is an automated macro which does the job for you. Just enter the raw data to obtain the coefficients. Now let's analyze the results to see if the method has brought us anything. We're going to compare 3 cases. First is with rebound hammer alone. The second is with the UPV, and the third is with SONREB. So case 1 is the rebound hammer strength estimation, and here you can see the graph of the regression value against the core strength value, and we have an 86% coefficient of determination. Case 2 is to use the UPV regression, and in this case we have a 72% coefficient of determination. And finally, we will use the SONREB regression. And you can see in this case, we have a 94% coefficient of determination, which is a significant improvement on the estimate. And this is why people are drawn to use the SONREB method. The main drawback to the SONREB method is the additional effort required on site, but this effort can be significantly reduced if we use pulse echo to measure the pulse velocity, and this is a technique which I first saw successfully demonstrated at an FIB conference back in 2016, and of course since that time the pulse echo technique has become standardized. So to summarize strength assessment with SONREB, it's a combined method for improved accuracy of the compressive strength estimation. It is recognized but not covered by EN 13791. It provides a regression for mean strength which can be then used at any specific location. On-site effort can be significantly reduced by using pulse echo measurement of UPV.